All right, let's get started on time. There's a lot of ground to cover in this one, so let's max out the time slot that we have. Bonjour, welcome to this session on basically Spring Framework 4.x. It's titled, of course, Modern Enterprise Java Architectures with Spring 4.1 specifically. So we're going to talk about the state of the art, and that's at this very moment Spring Framework 4.1 and the ecosystem around it. I'm going to have just a very brief Spring Framework 4.2 outlook towards the end, since 4.2 is not actually that far away. So what are we going to cover? Well, from my very own perspective here, I have been serving as the Spring Framework project lead, the open source project lead, for 12 years now. So from my perspective, I'm strongly involved in a coherent design arrangement for Spring overall, for Spring Framework's core component model in particular. And this is essentially what this presentation is about. We're going on a tour through the core Spring programming and parts of the configuration model. And we're going to look at it from a design perspective primarily, and also from a what does it kind of enable perspective, right? What kind of application architectures can you build with this component model? How does it adapt to different kinds of application architectures? That's also kind of a theme that goes through the presentation. All right, well, let's get right into it. There really is a lot to cover. Spring Framework 4.1 is, of course, the current generation. And the kind of arrangement that we have with Spring Framework 4, the Spring Framework 4 generation, is summarized here. Spring Framework 4 is strongly oriented towards modern-day infrastructure, Java 8, compatibility with kind of J2EE 7-oriented deployment environments, that's Servlet 3.1, the WebSocket specification, and so forth. So it's very much oriented towards the present. At the same time, there's sometimes a little bit of confusion about our backwards compatibility with older infrastructure. So I'm explicitly summarizing it here and stating it here, that Spring Framework 4, and this includes 4.1 and the upcoming 4.2, remains compatible with Java 6 and higher, Java SE 6 and 7, and of course 8, right? It even is runtime compatible with Servlet 2.5 containers still, which includes the likes of WebSphere 7, Google App Engine. Both of them are not yet, WebSphere 7, of course, from its generation, didn't have Servlet 3 available, but Google App Engine is also quite interesting. There are cloud deployment environments, platform as a service environments, which are not exactly up to date in terms of the Servlet specification and other specs that they support. So we recognize that. And that's a strong reason why we have a pretty broad runtime compatibility arrangement. So it's Java 6, 7, 8, it's Servlet 2.5, 3.0, 3.1. It's your choice of the infrastructure generation that you're using Spring on. Well, maybe it's not your choice, right? Maybe you're deploying to a data center environment. This is a strong part behind the Spring Framework story. Spring adapts to your runtime environment. It adapts to your application architecture as well, right? Your kind of vision, your understanding of how your application is best structured for your purposes. But it also adapts to any given runtime infrastructure. If you're deploying to WebSphere 7, kind of Spring Framework 4.1 auto-scales, auto-adapts to what WebSphere 7 can do for you. We're trying to get the maximum out of the runtime infrastructure that we're being deployed on. So you're getting the most out of what you have, basically. And there's an interesting sweet spot these days. Quite a few deployment environments where you can upgrade to Java 8 underneath. Please do so. This unlocks a lot of potential, a lot of stuff that you can do, in particular within the Spring programming model. Even if the application server environment or whatever you're running on top there may still be a J2EE 6 generation, there may be an option to have Java 8, JDK 8 underneath. Some vendors officially support this. This is also a great environment to deploy Spring 4 applications onto. All right, so much for a little bit of introduction. Here, let me just summarize what this means in terms of specifications. Those are all specifications that matter to us, right? That have a relevance within the Spring programming model. And as of Spring Framework 4, we support them in the J2EE 7 incarnation. If you happen to find it in practice, since J2EE 7 hasn't quite made it into the production market yet, as you may be aware. But if you can find it in production, if you have it available in production or can include compatible providers into your production environments, maybe add JPA 2.1 providers to Tomcat and so forth, choose Tomcat 8 to begin with, then of course Spring is there to serve for you on such platforms. All right, let's get right into it. We're going to go through quite a few sketches of code, right? Just examples that are reduced to make a few points about the component model. The core of the component model is essentially shown here, right? A component in Spring is an annotated Java class. It's basically saying, I've got this class here, and through the use of component annotations, I'm expressing certain characteristics. I'm adding, for example, a strong formal notion that this service is an add service, that this is not just a class that's named service in its name, it's also formally declared as an add service. That's a stereotype. Basically the same as the good old UML stereotypes. It's formally declaring that a class has a certain role within your code base, a certain role within your architecture. That's not the only kind of annotation found here. There are a couple of others. At the constructor level, for example, we have @AutoWired, which is a dependency injection annotation. And there are a few of those in Spring. It's not just @AutoWired, there's @value, @persistence context, @inject, of course, as a standard version of @AutoWired. But all of those are injection annotations. They demarcate, they declare injection demand. You're basically saying, I want, with no other configuration given, I want this constructor to be selected among the available constructors for injection purposes, with each of its constructor arguments, in this case account repository, being resolved as a dependency by type and by qualifier information. But basically that's by type, right? Be as expressive as you can in terms of the type that you're declaring here, and the container is going to provide a matching component to you, if there's a unique one, according to the rules. So that's injection annotations. We're going to spend a few more minutes with those in just a bit. @transactional, at the method level here, update book level here, is another kind of annotation. It's a declarative way to tap into a middleware service. It's expressing transactional demand, and it does so through a kind of formal annotation saying @transactional. The rule being that if this subsystem is being active, if you've configured annotation-based transactions, then we automatically intercept the method, start a transaction before we call the body of the method, and we commit or roll back after the method returned. Right? So that's kind of what you're doing with those annotations. But let's switch it just a bit. From a design perspective, those annotations just add a few characteristics to your source code. It's a myBookAdmin service. It's formally declared as an add service. It expresses injection demand. It basically gives a hint of some sorts, but it's basically a characteristic, right? This is an AutoWired constructor. It even reads that way. It's a transactional annotation. A transactional method, sorry. Those annotations tell you something about your source code. They add characteristics to the source code that are otherwise not formally declared. In that sense, they add to the readability of your source code. If you just run into this piece of source code a year or a couple of years later, the annotations still tell you something about the intention of that piece of code. So annotations basically have two roles. Essentially, they have two roles. It's, of course, the kind of framework-related role. They allow you to tap into some framework services. The framework kind of adapts to them and does something for you if you declare them. But they also have a role within the source code, adding to the readability of your source code. All right. From a configuration perspective, this is one way, and it's elaborating a few things, to configure your beans, your components in Spring. This is a configuration class. A configuration class has an add configuration stereotype. It may have a few additional characteristics, such as it may declare to just be active in a specific given profile at runtime, if that profile is marked as active at bootstrap time. It may activate annotation-driven annotation support, which at Enable Transaction Management does. But its most important part, it may have add bean methods. Each of those add bean methods adds a bean to the available beans at runtime, right? Spring has an application context concept. There's any number of beans registered in there from many sources. Those may be internally created beans. They may be components that you declared, added as a bean. The add bean method here is kind of the most direct way of just taking a Java class, or actually returning an instance of a class that you implemented, and adding some metadata characteristics to it. So the add bean method is a factory method. Whenever the container needs to create a new instance of this bean, it's going to call that method. So for a singleton bean, it's only going to be called once usually. For a, say, session scoped bean, it's going to be called for every session that somebody requests access to this bean for. So that's add scope session is kind of the raw version of suggesting to the container that this instance is supposed to be managed under session scope. But fundamentally, it's a factory method concept. This is the most powerful and the most flexible version in Spring. There are, of course, significantly simpler ones. You can just do component scanning. When you do component scanning, all you do is you send the container on a search through the class path, finding such components annotated with add service above or with add controller, add repository, equivalent compatible component annotations. And the container is going to auto-register them for you. That's just a component scan instruction with a base package declared. Any matching component of this kind is going to be automatically registered for you at runtime. This is significantly more powerful. It allows you to just fine-tune the instance, to add some additional configuration to it, refer to other beans by a reference to the factory methods, and to add additional characteristics at the method level here. It's particularly useful if you would like to configure several instances of the same class as well, with different bean names, because the method names the bean name here. So just having several add bean methods, even if they return the same type, every such method can fine-tune each instance. So a very powerful concept, configuration classes in Spring. The annotation model itself is highly composable these days. So whenever you see standard Spring annotations in use, always keep in mind that you can build your own annotations for the same purposes. It's a very powerful model, because if you look at just this little extracted class here, my book admin service now has a my service annotation. My service is, obviously not an ideal name, but my service is an annotation that you can build yourself. It's declared above. It's a public add interface my service, a custom my service annotation, and it's meta-annotated with the standard service annotation, with a default scope of session, with a default transactional rule, and even with a default primary characteristic, which means it's going to win over other beans of the same type when somebody asks for my book admin service to be injected somewhere. So quite a few characteristics from Spring's ways of doing things being combined into a single, short, concise my service annotation. Every time you're saying add my service on any of your classes, you're kind of combining those characteristics above into one little sweet shortcut. This little shortcut is not just a shortcut, it's a stereotype annotation still, right? So by all means, please don't call it my service. In any concrete code base, right? There is going to be a better name. Call it order service, call it customer service, call it something that makes sense within your code base, within your application architecture. A stereotype is a way to indicate a specific role in your code base. So give it a meaningful name, and at the same time, let it have some default characteristics through meta annotations. This is a really powerful model. And in the end, you're using your custom annotations in your code base. It's a way to be more specific and more customized for the use of annotations in your code. If you'd like to avoid just using standard Spring annotations all over the place, this is a way to replace them with custom annotations of your own. All right. The composable annotation model even has, as of Spring Framework 4, has a way to override attributes. There are some just brief examples of what you can do with this. You can build custom scoping annotations. An @mySessionScoped annotation is a custom scoping annotation, can be meta annotated with scope session. So it's also a way to get rid of this session string, because the scoping model is, of course, open in Spring. You can register any number and any names for scopes. This is one way of having kind of a type-safe mySessionScoped annotation. But it's not just a shortcut annotation. It has an attribute, right? It has a proxy mode attribute here. Proxy mode overrides the same named attribute in the standard Spring scope annotation. So you can declare a proxy mode attribute to have a custom annotation and nevertheless an annotation attribute for some flexibility, in this case, the choice of proxy mode. So it's a pretty sweet model. Some characteristics can be fixed. The name session here, the scope session, that's fixed. Every time somebody says @mySessionScoped, there is no way to override this, basically. It's hard to code it at that point. But the proxy mode is still flexible. This is a way of guiding a developer team in the end. If your development group, your project team here, is supposed to only use certain combinations of characteristics across your code base, provide them with such custom annotations. Those annotations can allow for whatever needs to be customized and can hard-code whatever you want hard-coded, whatever you want your developers not to customize. So, for example, the scope arrangement. The example below, @myTransactional, also has a sweet characteristic to it. It's, of course, the same idea. It's a custom transaction annotation. You can put that on any method in your code base. It's going to have transactional characteristic at that point. As usual, it's meta-annotated with a Spring @transactional annotation, but it redeclares a read-only attribute, which is one of the attributes on Spring's @transactional. It doesn't redeclare any other attributes. So there's, for any user of @myTransactional, there's no way to customize the rollback rules, to customize the timeout, to customize anything else really. Just the read-only attribute. And the sweet spot here is the read-only attribute does not declare a default value in the annotation. Every time somebody uses @myTransactional, they need to specify the read-only flag. You're forcing them to say read-only true or read-only false. If you don't want to force them, just declare something here, right? Default false, for example. This is one way of kind of guiding a development team as well. You're forcing people to make up their mind, to reason about that specific transactional boundary, whether it's effectively just doing read-only operations, which means we can optimize for them here, or not, right? You could, of course, also compose several versions of that annotation. You could have a my read-only TX annotation, meta-annotated with transactional read-only true, and another version of that annotation, meta-annotated with read-only false, right? You could also combine them into several annotations that people are supposed to use, or you go the attribute way. All right. Another somewhat recent feature in the component model is the use of types. The use of generic type declarations is in Spring Framework 4 treated a little bit differently than before. So if you've got an injection point, like down here, an injection point that says my repository of account, we're going to take that into account, right? Fully into account. So we're going to use the entire generic type information, my repository of account here, and we're going to look for a bean that's assignable to that specific declaration. So with the two beans above, they probably live somewhere else, right, in a configuration class or whatever, right? Those are really different pieces of code, just shown together on this slide. So if you've got a configuration class that happens to declare a my repository of account and a my repository of product, if your injection point is specific enough down here, if this is expressive enough, then we match it with the declaration here. That declaration may be in a factory method, it may be in the class, right? If the class says implements my repository of account, we can also evaluate that information from the class itself. So if we can, we're going to try to find the closest match for you. Because fundamentally, we need a unique match. If we can't make a unique match here, if the framework encounters several matching beans according to its rules, it's going to say, sorry, not unique, right? You're asking for a single instance, but I've got two my repositories. But since you were expressive enough here and said of account, we're going to skip that part and going to take that single instance for you. In Spring Framework 3, you would have gotten a not unique exception unless you added additional qualifier information. So in Spring Framework 4, you will hardly ever use qualifiers. Qualifiers are just extra metadata added to beans in order to select them if they happen to implement the same type. As of Spring Framework 4, the recommendation is to be as specific as you can in your type signature. If you can go that way, use a generic type variable. If that's expressive enough, there's no need to add an extra qualifier account or something. No extra metadata needed if the types themselves are expressive enough. That's a pretty nice rule as of Spring Framework 4. There's another sweet spot for the variant where you don't want a single my repository. You want a list of my repositories of account. First of all, of course that works, right? You asked for a list of my repositories of account. So we're going to look for all beans that are of primary type my repository and happen to declare the account variable. Happen to substitute the variable with account here. So if there are two my repositories of account, we're going to accumulate them into a list for you, and that list is going to be injected into the constructor. A sweet spot here is the ordered injection as of Spring Framework 4. So you can declare an add order value at the add bean level, for example, or at the add component at service level on an implementation class, works the same way. That's an order value that we're going to take into account whenever we need to build a list or an array. So if you ask for a list, you get a pre-ordered list according to those order values above, a pre-ordered list of my repositories. That can be pretty important if that list represents kind of a search arrangement. Check the first one first. If you don't find it on the first repository, go to the next one, right? There may be a business meaning, an algorithmic meaning to the order in that list in your application arrangement, and that can be expressed through add order values now. Another variation for injection points is add lazy. That's pretty nice as well, since it allows you to demand lazy initialization semantics at two different levels now. You can do it at the declaration level for a bean, like add bean up here, can have an add lazy annotation saying, giving a hint to the container, please, if you can, lazily initialize this bean. If nobody requests it on startup, don't initialize it yet, right? Even if it's a singleton bean. Only initialize it once somebody requests access to it. That's what add lazy means above. Add lazy can also be put down here now, at the injection point. If you're saying, I want this my repository of account, and I'm going to consume it in the constructor because I prefer constructor injection, but I'm not going to use it right now. I'm just going to store the reference in some variable. I'm going to use it later on when some method calls come into me, into that my book admin service. That's what you can express with add lazy here. You're basically just saying, I want this reference here, but I'm not going to use it, so a lazy initializing proxy is perfectly okay for me. And that's exactly what you get. A lazy initializing proxy, implementing my repository, and whenever you access it, it's going to trigger the actual creation of the target bean in the Spring container. So add lazy is a pretty powerful way of expressing that. And it's nice to read, right? It's a lazy reference to a my repository. And this is a lazy bean declaration above. So it's also it adds meaning to the source code as well. You're expressing something in the source code. I'm not going to use it right now. I'm going to use it later on, right? It's something that also that's also meaningful within your source code arrangement. JSR 250 and JSR 230 are basically standard specifications from the JCP, so living in the JavaX namespace, and they've been supported in Spring for many years now. So just showing it here that components can also be declared this way. You can even use the add managed bean stereotype above at the type level, not using the Spring component stereotype model, but using a standard non-composable annotation in the form of managed bean here. You can use add inject instead of add autowired for injection demand, and you can use add post construct and add pre-destroy for after configuration and pre-destruction callbacks. So for init and destroy methods in Spring terminology. So it works exactly the same way. Doesn't need any extra configuration. Just use those. Just use them. And Spring happens to auto-detect them. So there's no extra configuration needed for this. Just use them in your source code, put it into the same location where you've configured Spring to find its stuff, and it's going to automatically pick them up and react to those annotations, just like it does to its own annotations. Down this line, there's a nice new feature in Spring Framework 4.1, which is optional injection. So saying, expressing that you don't insist on that target bean to be injected to you, to be available in the first place. Java util optional in Java 8 is a nice way to express this. There's another way, that's the JSR 430 provider interface. Basically, there are other ways to get similar behavior, right, with at least lazy access to it. But optional has a very specific semantics. It's a bit like, it's more like add auto-wired required equals false. If you remember that from Spring standard annotations, if you've ever used that attribute, this is basically the closest what we have to Java util optional here. But you don't have to say required false anywhere. The non-required optional characteristic can be inferred from the type. Right? You declare optional of my repository of account. That's exactly what you get. You get a Java util optional instance, which may have a reference to a pre-resolved my repository of account if it's available in the context. If it's not available, you get an optional empty instance. Instead of with add autowired required false, you would get a null reference, right? And in the Java util optional model, you can react to that through saying is present and so forth. The Java util optional style. That's a nice way of expressing those characteristics as well. It continues our story of expressive types. No extra metadata needed, no extra attributes on those annotations. Just a type signature that's expressive enough to say exactly what you needed to say for the runtime behavior that you want to get in the end. Right. Somewhat related in terms of this expressive type story is formatting. As of Java 8, we got a standard java.time package in the JDK, similar to the Joda-time types, and we support it just like we supported Joda-time before. We still support Joda-time, by the way. So for Java 6, 7, and even 8, if you continue using it there, you can still use Joda-time the same way. But the java.time package is even nicer, right? It's a common way of expressing this. Java 8-based frameworks and infrastructure is going to understand it automatically. And so does Spring Framework 4. Whenever you happen to use java.time types such as local date and local date time in your source code, Spring's binding and formatting infrastructure is going to auto-detect those and automatically adapt to those. So incoming string, values can be converted to local dates, local date times. They can be rendered out as string values to web views or to JSON representations or anything else really. And Spring's common way of fine-tuning those formatting rules is the @datetime format annotation, which is typically used next to constraint annotations. So if you have bean validation constraint annotations such as not null and passed, wherever you put those, you also put the @datetime format annotation. You can suggest a conversion and rendering pattern, for example, for dates. However, if the type itself, the field type itself, is expressive enough, you don't necessarily need to add a formatting rule anymore. Because if you're saying local date, the type itself says this is a date, right? No time part included. It's a standard date representation. So our binding infrastructure in Spring, by default, uses the ISO date representation. Because the type itself suggests that, basically, right? For local date time, we're going to use the ISO datetime representation. This is pretty nice because it means you can omit the annotation, right? This is commented out for a reason. You can just omit that line. You don't have to have it there. Because the type itself is expressive enough. Only if you deviate from what your type suggests by default, you need to add a formatting rule through @datetime format here. The same arrangement works for Java.time, right? So this is, with Java.time, it's even more compelling, I would argue, but it also works with Java.time. Declarative scheduling, for timing reasons, let's discuss some of those services a little bit more quickly. In Spring, there are ways to suggest asynchronous execution. For example, @async on a method call allows an incoming call to be automatically forwarded to a thread pool. So Spring's going to intercept the call, build a callable, pass it on to a pre-configured thread pool that you configured through Spring @enable annotations or the task namespace in Spring. And you automatically send the call to a thread pool through just a simple declarative annotation @async with either a void return type or a future if you want to kind of keep tracking what your asynchronous piece of code does here. You can also declare a future result, a future return type, and the caller may hang on to that future and just evaluate it the same way as if you were talking to an executor service. Right, but even more specifically here, we have an @scheduled annotation. @scheduled is a kind of trigger-based callback. Any method that's annotated with @scheduled will receive a callback if the infrastructure is configured, right? There needs to be the task namespace or @enable async with a thread pool that you configured. We don't use a default thread pool here. In Spring, it's always what you configure is what you get. This in particular applies to such infrastructure, thread pools in particular. Right, but if such a thread pool has been configured centrally for this application, you may use @scheduled, associate any kind of trigger, but typically cron triggers. So there's a cron attribute that takes a cron trigger. Whenever the trigger fires, you're going to get an invocation of that method from your configured thread pool. This is pretty nice from just a asynchronous execution perspective. But from a design perspective, note that we have repeated @scheduled annotations here. There are two @scheduled annotations on the same method. That only works like that as of Java 8, because our @scheduled annotation is meta-annotated with Java 8's repeatable. So it's declared as a Java 8 compliant repeatable annotation. The Java 8 compiler is going to accept it like that. So that only works because we declared it compatible with the Java 8 repeatable rules. In Java 6 or 7, you would have to have a kind of nested arrangement with an outer @schedules and a nested array of @scheduled annotations. This is much nicer because it's the most concise version of expressing it and very naturally integrates into corresponding parts of the Spring programming model. Right. Just making the point that since we're talking about Java 8, lambdas, of course, work the way you expect them to work, right? Just take Spring's JDBC template, a pretty old API in Spring, really. I mean, this API is more than 10 years old. but works very, very nicely with lambdas. This is the same call, just shown two ways. Maybe the second version below is a little bit more compatible with the typical Java developer's eye, right? It looks a little bit more like inner classes if you use the bracket style here. If you nest the body that way, but the more concise version is of course shown above. This is inline lambda expressions where you're building a kind of callback that the target API requests from you. In this case, Spring's query method takes a SQL string, it takes a prepared statement setter, and it takes a row mapper. And you're fulfilling that signature here, right? You pass in a SQL string, there's this PS set string, one line nested expression, embedded expression, which is going to be converted to a prepared statement setter implementation. And the third line, the new person line, is going to be converted to a row mapper implementation, like some implementation of the interface row mapper implements row mapper with a map row method, blah, 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 blah. It's much more concise here, right? Declaring the incoming parameters to the callback method, RS and the result set and the current row number, and just an expression to be returned for every call into that interface, right? So for a callback style API arrangement, this is a perfect fit. And in Spring, JDBC template, transaction template, all those callback style APIs that we happen to have for more than 10 years are perfectly Lambda compatible here, without a change in the signature, because we're simply using the same convention. The Java 8 Lambda convention works perfectly for the arrangement that we chose 10 years ago here. So that's a pretty sweet spot as well, and a pretty good reason to start using Java 8 with Spring, by the way. All right, to wrap this up, a couple of examples that I'd like to show you quickly for what some of the endpoint components may look like in Spring. This is a Spring MVC controller. Has a stereotype add controller above, can be found the same way any other component can be found in Spring through component scanning. And it expresses a mapping rule through a method level annotation called addRequest mapping here, binding a specific handler method to a specific HTTP path. You may use path variables as indicated up here with parameter levels annotations binding into those specific path variables. So that's an arrangement we've been having for a while. Works quite nicely, and it's very, very flexible. Any number of arguments supported here, as long as each of those arguments can be resolved, oftentimes through a parameter level annotation added to it. What's also pretty nice is that as of Java 8, we have a way to resolve those parameter names, just as a side note. Right? In order for this to work, because there may be any number of path variables, we need to be able to resolve variable names. As of Java 8, that's a first-class compiler feature. If you compile with JavaC -parameters, it's going to have a first-class representation of those parameter and constructor names in the bytecode of your class files, right? And Spring can resolve them from that section in the bytecode. If you happen to use Java 6 or 7, the only way to do this is to let Spring reparse your class files using ASM and to compile those class files with the -debug compiler instruction. So the short version of that story is, as of Java 8, this is a first-class feature. It's really nice for Spring's endpoint model because in particular at the handler method level, there is no need to repeat the name of the variable, the parameter, the header that you're referring to here. We just take the parameter name as declared in the source code. That's the name that we're going to use at runtime. Very nice fit. The same works for example, stomp endpoints. You'll find yourself familiar here. Subscribe mapping and message mapping have a specific meaning in @stomp, in the stomp protocol, so subscribe requests or regular messages. This is Spring's way of expressing endpoint handler methods for the stomp protocol on WebSocket communication channels. Aside from what we do at runtime here, just look at the design here. Looks very similar to the regular endpoint model for HTTP endpoints in Spring MVC. We have a similar way of expressing endpoints for regular GMS messages as well. So the previous slide was stomp messages on the WebSocket channel. This is our way of binding handler methods to incoming GMS messages. This is a short version with hardly any extra metadata. And just to make a point here, it is very, very expressive, right? You can fine-tune a lot of characteristics if you insist, right? And if you need to, you can fine-tune them for each of the handler methods through annotation attributes. The arrangement is very similar again. It's a consistent design arrangement. Annotation-based handler methods, incoming messages, incoming requests being bound to such handler methods through metadata expressed at the method level. So this is, as of Spring 4.1, GMS messages, and this is a slightly different way of structuring the endpoint method, but it's in particular also bound to different messaging protocols, right? It's using the GMS API here. It's using the Rabbit AMQP client here for incoming messages to that method, and this is the Stomp version, typically used with Stomp. Just look at the design arrangement. The method signature is always the same. You can use the same message types. You can use the same message signature for returning a response message. The mapping annotations are different because the protocols are a little bit different, right? They are fine-tuned and adapted to the power of each of those protocols. But syntactically, they are very similar. So, same common message endpoint model for different kinds of protocols and arrangements. Right. And since we're already running out of time, and I've got a short demo still coming up, let's just look at this for a few seconds here. This is how to express caching demand in Spring. In the meantime, you should find the syntactical arrangement very common, right? This is Spring's version of those caching annotations. As of Spring Framework 4.1, you can also use javax.cache annotations from JSR 107 to express the same kind of caching demand. Caching demand is a little bit like a transactional, right? Whenever the call comes in, we're going to intercept it for you, and we're computing a key, and we're going to find out whether there's a pre-cached value for this call, and going to return it instead of calling the target method. If there's no such value, we're going to call the target method and going to put the value into the cache for you. The syntax is very similar to other such arrangements in Spring, once again. All right, and leading on to a short demo, there's a nice little sister project that we have, Spring Boot. And Spring Boot allows you to be super efficient in getting started in particular, but also in expressing common configuration arrangements in Spring. So it's a sister project of Spring Framework, currently in version 1.2. And we have Spring Boot 1.3 coming up, along with Spring Framework 4.2. So there's a nice little continuation of our annotation-based story summarized here. That's what we're currently working on for a GA release in July. A lot of current features, some of them third-party initiatives that we adapt to in Spring Framework 4.2, and some, like annotation-driven application events, for example, are a nice little addition to the overall Spring annotation-based component model. So this is what's kind of coming up next in terms of fine-tuned details. So at this point, let me invite Stefan up to the stage for just a short demo. We might go a few minutes over time. I hope you're bearing with us here. But you're going to get a nice little impression for how this can be used in practice.
Oh, crap. Oh, okay, I'm good. So I have 7 minutes. So let's see what we can do in 7 minutes. So the first thing is, if you don't know about this website, start.spring.io, it's a means for you to create very easily a new project, a Spring Boot-based project, where you can define the characteristics of your project on the left and pick and choose dependencies on the right. Spring Boot is over a year old now, and we've started to integrate more, adding more integration into build tools and all kinds of things. And what you can see here is, in the latest version of IntelliJ IDE, there is this wizard you can use to basically do the same thing as creating the project from that web interface. So what I'm going to do is I'm going to create very quickly a web application. I'm going to use security on that web app. I'm going to create a GPA repository. For that, I need a database. And I'm also going to expose those as REST endpoints, so exposing the repository as a REST endpoint. And I'm also going to choose the actuator, which gives all kinds of nice non-functional features. Okay, so if I do that, I have a simple project. So I choose Maven as default, but you can use Gradle if you want to. And what I'm going to do very quickly is I'm going to create a speaker with a template so that you don't see me coding for nothing, which is very a basic object, a basic GPA, standard GPA entity with a first name, a last name, a Twitter account, and a bio. I'm going to also create a speaker repository for that speaker, which is really a standard Spring Data repository, CRUD repository in this case. And since I added Spring Security, so I added the security checkbox, what's going to happen is everything will be secured by default using basic authentication. And we're going to create a user with the default name user. And we're not going to create a default password because that would be nasty if we put the default password in the documentation. So every time we start the app, what we basically do is we generate a password. So I don't want that. I want to fix the password. So for that, I can use a property. And I would need to know the key. And fortunately, in the latest release of STS and the latest release of IntelliJ IDE, I have auto-completion in the IDE. So if I type password, then I have all the keys that matches according to the current environment. And if you want to use that infrastructure for your own keys, there is a way to integrate your own keys into that content assistance. So I'm going to try change me here. And a Spring Boot application is really, really simple. It's really back to the basics. It's like a simple main class, and you just run it, right? As simple as that. And if I do this, so that was quick, 3 minutes. And I go to, let's say, localhost speakers. And I didn't have to log in because I probably forgot to clean my cache. Then I can see that I have a REST endpoint here. And the REST endpoint is fully functional. So I could, for instance, I could actually post a JSON document to that endpoint, and it will create a speaker for me. So that's what I've done here. Let me show you first the script so that there is no mystery. So it's basically looping over all the JSON file in that directory, and it's basically posting to the speaker's endpoint with JSON content type. And it needs the user and the password to do that. So you can see it created all kinds of speakers, so the ones that are basically in the local directory. I'm getting the proper HTTP response and also a location. And for instance, let's take this one, speakers 2. And then I have a speakers. And if I go back to this list, I have all my speakers. So that's how quick I could create a very basic Spring application. So I still have 2 minutes. So I'm going to try something. Let's see. I'm going to create an event listener, repository event listener for speaker. So basically what I'm going to do is, it's a bit convoluted, but I'm going to create a listener that's listening on a new speaker being created. So for that, I'm going to use handle after create, which is something from Spring Data and nothing to do with boot. And what I want to do is I want to post a nameQP message every time a new speaker is created, just to show you how productive you can be. But I haven't checked the MQP support, so I don't have that. And as you can see, all the technology that I've chosen in the wizard, they are being represented here as starters. So that's the notion of Spring Boot Starter. I'm going to add a new one, which is Spring Boot Starter MQP. And once I have that, I can basically inject a Rabbit message operation, which is the object that I can use to send an object on a certain queue. And that's what I'm going to do here. I'm going to say, I'm going to send that to a queue named speakers, and I'm just going to send the speaker object. And I need that queue to exist, so I'm going to create it on startup. Speakers queue. Yes. Right. My time is up. Give me 1 more minute. Maybe 2. And the other thing I need to do now is create a listener. So I'm going to say speaker service, for instance, whatever the name you choose at this point. And I'm going to say handle new speaker. So I can basically choose whatever method signature I want. Retrieving the speaker, and let's say I want to lock something. So that should be logger info. With a void, probably works better. And if I want to actually create a message listener container under the covers to process that Rabbit queue, I should add Rabbit listener and basically go back with my speakers queue. And probably have RabbitMQ running, probably would be a good idea. Okay, let's try that. It will probably break because I forgot something, I'm sure. So if I'm restarting this app, oh yes, I forgot something. No, I didn't. Maybe not. We'll see. Well, if I do that and I run it again, then I can see that my listener has received the message. So basically in 10 minutes, I created an app with a speaker, with a GP entity, a repository, being exposed as a REST endpoint. I created a listener to send an MQP message whenever a new speaker is created, and then I have created a listener to receive it. I wish I would have the time to actually do the same thing in the cloud, but you know, time is up. Thank you.
All right. Just one final